Okay, so for 32, let r of x equal this function, find our inverse in terms of y. So whenever you find an inverse, generally you can kind of think about like solving for whatever variable is normally here. So for this one, we have our function r of x equals 3x minus 4 over 2x plus 5. So if we solve for x, we should be able to get the answer, and this is also going to be equal to y. So to solve for x, first thing we can do is move 2x plus 5 to the opposite side. And then from here, we can move all of our x's to one side of the equation. So we have 3x minus 2xy equals 5y plus 4. And now from here, we can factor out an x from both of these. So we get 3 minus 2y equals 5y plus 4. And then divide both sides by 3 minus 2y. So we get x equals 5y plus 4 over 3 minus 2y. And this is also equal to our inverse here with respect to y. So our -1y, our inverse, is going to be 5y plus 4 over 3 minus 2y. And just to quickly note, this could also equal negative 5y minus 4 over 2y minus 3. And this is from just factoring out a negative from both of them. These two are the same answer here. Okay, so looking at 33 here, let y equal f of x equals 2 times the square root of x minus 5. Find our inverse function and the domain and range of our inverse. So again, just like on 32, our general kind of strategy is we want to sort of solve for x. So if we have y equals 2 times the square root of x minus 5, to solve for x, the first thing we can do is maybe we can try dividing by 2. So we'll have y divided by 2 equals the square root of x minus 5. So now we can square both sides. So if we do that, that will get rid of our square root. This is squared here. And then we just want to add 5 to both sides to get x by itself. So y squared over 4 plus 5. Okay. And solving for x also gives us our inverse function in terms of y. So now we just need to find the domain and range. So for finding our domain and range, we want the domain and range of our inverse function. And this is a little bit tricky because if we were to just look at this here, it looks like there's nothing stopping our domain. But if we look at what our original function is, our original function looks something kind of like this here. Notice how our possible x values are from 5 to infinity, right? So 5 to infinity. So this is the domain of our original function, and the range is 0 to infinity. So whenever we find the inverse function, the domain and range are going to be swapped. So this is the domain of our original, this is the range of our original. So the domain of our inverse function is the range of our original. So domain is going to become 0 to infinity, and our range is going to be, bracket, 5 to infinity. And again, the inverse function, f inverse of y, was just equal to over 4 plus 5. Okay. And again, that's because here, for this part of our original function, we only have this here. If we had something like this, then maybe we could get something that kind of lines up more with what we would expect if we were to just look at this inverse here. So it's a little tricky, but just look at your original function and find the domains and range, and then swap them to get the domain and range of your inverse.
Okay, so looking at 34 here, salt water is flowing into a large tank, and the concentration C of T of salt in the tank is given by C is equal to F of T, which is equal to 1.2 T over 100 plus 6T pounds over gallons, where T is in time and minutes after the salt water started flowing in the tank. So we want to find F of 20. So anywhere we see a T, or in our function, we want to plug in 20. So F 20 is going to equal 1.2 times 20 over 100 plus 6 times 20. So our numerator comes out to 24, and our denominator comes out to 220. So when we simplify that, we're going to have 24 divided by 220. It's going to leave us with 0.1091, and that is in pounds per gallons. And what does that mean in terms of the problem, right? So essentially what that means is at 20 minutes after the salt water started flowing, into the tank, the salt concentration is 0.1091 pounds per gallon. All right, so we're looking at 34b, find the inverse of f of t, or c. So c is equal to 1.2 t over 100 plus 60. So first thing I'm going to do is multiply both sides by the denominator of 100 plus 6t and 100 plus 6t, right? So we're going to have 100 plus 6t times c is equal to 1.2t. So next thing I see is I'm going to distribute this c, so 100c plus 6tc is equal to 1.2t. I want to get all the t's together so I can solve for t. So minus 6tc minus 6tc, so 100c is equal to 1.2t minus 6tc. So next thing I want to do is factor out a t on the right side. So 100c equal to t times 1.2 minus 6c. So now I'm going to divide both sides by 1.2 minus 6c. 1.2 minus 6c. So that means that we know that t is equal to 100c over 1.2 minus 6c. So that means that f inverse of 1 of c is equal to 100c over 1.2 minus 6c. Or another way to write it is negative 100c over 6c minus 1.2. And we did it just by dividing on a negative. So now we're looking at 34c. So we want to evaluate f inverse of 0.15, which on the previous problem we said was negative 100c over 6c minus 1.2. So anywhere we see a c, we want to plug in 0.15. So f of inverse of 0.15 is going to equal negative 100 times 0.15 over 6 times 0.15 minus 1.2. So that brings our numerator to negative 15, our denominator to negative 0.3, which just simplifies down to 50, and this is in minutes, because f inverse of c is also equal to t. It's also equal to t, which we said in the first part of the problem is in minutes. So what does that mean in terms of the salt concentration? Well, the salt concentration is 0.15 pounds per gallon at 50 minutes after the salt water started flowing into the tank. Okay, so we want to find functions f and g are given below. F is a table and g is a graph. So we want to find f of g of 0. So the first thing we want to do is find what g of 0 is. So we're going to come to our graph. X is 0, g is 1. So now we want to find what f of 1 is when x is equal to 1. So when x is equal to 1, f of x is equal to 2. So f of g of 0 is just 2. So 2. Next we want to solve for g of f inverse of 5. So f inverse of 5 is what we want to find first. And that's equal to x. So what is our x value? So f of x is equal to 5. So when f of x equals 5, what is our x value? So we look over here, it's going to be negative 1. So now we want to find what g of negative 1 is. So if we go over to our graph, g of negative 1 is 0. So that means that g of f inverse of 5 is equal to 0. Alright, so now we're looking at 36a. We want to solve for g of f of x is equal to 3 for x. So g of f of x is equal to 3. So we know that g of g's x is equal to 3. That's also f of x. So if we look back and we find out what when g's y is equal to 3, we're going to look at here, and then we're going to come across, and that's 2. So we know that f of x is equal to 2. So we want to find the x value when y is equal to 2 of f of x. So if we come here, we're going to go 2, come all the way across, and it's 8. So we know that for part A, x is equal to 8. All right, so next we want to look at 36b. So f inverse of 3. Another way we can write this is f of x is equal to 3. So we want to know what is x when f of x is 3. So we're going to look at our y values for f. So 3. And then we're going to come all the way across. And that looks like it's 6. So we know that x is equal to 6. So f inverse of 3 is equal to 6. All right, so we're working on 36c here. So we want g inverse of 4. So another way we can write this is g of x is equal to 4. So we want to look for what x is equal to when y is 4 of g of x. So we're going to look here, and g is this black line. So when y is equal to 4, x is equal to 0. So x is equal to 0. So g inverse of 4 is equal to 0. Alright, so we're looking at 36D here. We want to know what g of f inverse of 5 is. So we first want to know what f inverse of 5 is. So we can write that as f of x is equal to 5. So we want to go over to our graph and find what our x value is when y is 5 of our f function. So I'm going to go over here. Y is 5, come across, go down. So x is equal to 2 when y is 5 of our f function. So we're going to have x equals 2. So we want to know what g of 2 is now. So if we go over here, when x is 2, g is 3. So g of f inverse of 5 is equal to 3. So we're on our last question here of 36E. It's asking for what g of 6 minus f of 6 is. First thing we want to do is find what g of 6 is and what f of 6 is. So we're going to come over to our graph of g. When x is equal to 6, g of 6 is equal to 1. And then same thing for f of 6. So when x is equal to 6, f of x is equal to 3. So we can write that. So g of 6 is 1 minus f of 6, which is 3, which is going to leave us with negative 2. So now we know that g of 6 minus f of 6 is equal to negative 2. Write that over here. And yeah, that's the math review.